researchers have published a new update to Meta's model. This improvement is known as V-DETR, and it's built off Facebook AI's DETR framework. V-DETR represents a new way of finding objects in 3D pictures. This is different from the usual 2D object detectors that we know of. 3D object detectors locate items in a given 3D space. This could be a scan of the environment using a 3D scanner, photogrammetry, or LiDAR. So what sets V-DETR apart from its vanilla version? Be sure to watch till the end to find out all the details. Other 3D object detectors like DETR had a few downsides to them, and V-DETR aims to resolve these issues. Previous methods of finding 3D objects weren't very effective because they ignored where the object really was in the 3D space. What we mean by this is that the detector would point toward objects that were far away from the intended target. For example, if a picture contained a chair, the detector would instead look for points away from the chair rather than points near the chair. Researchers say that this violated the principle of locality in object detection. You would end up with suboptimal results using these methods. And this was down to the fact that these models failed to learn how to properly perform their tasks given their limited training data. The researchers introduce a new way of finding 3D objects in pictures. They call this 3D-VRPE, which stands for 3D Vertex Relative Position Encoding. To put it very simply, this method pays attention to where the objects are in the picture by using boxes to represent them. For example, if there is a chair in the picture, it uses a box to show where the chair is. Then it looks at points that are inside the box and ignores points that are far away from the box. This makes it easier to find the chair while also adhering to the principle of locality at the same time. They've also improved some other things, like how they prepare the pictures for finding 3D objects. They also tested V-DETR on two very challenging benchmarks that have many 3D objects in them. These sets are called ScanNet V2 and Sun RGBD. They are very popular and challenging for finding 3D objects. V-DETR works very well on these sets. Not only can it find more 3D objects, but it can do it even more accurately than previous methods, even setting a new record in the process. But before we get into too much detail, let's discuss why 3D object detection is so important in the first place. As mentioned before, 3D object detection is an entirely different ballgame than 2D object detection. It's done using something called point clouds. A point cloud represents the XYZ coordinates of an object. It covers the entire external surface of an object and can even include color information. Point clouds are important because they can be converted into other formats to be used in 3D modeling. It is essentially a gateway for accurately generating a virtual replica of a real-life object in a relatively shorter amount of time when compared to modeling the object manually. Point clouds are very useful in various industries like VR, Arkansas, education, preservation, self-driving cars, safety inspections, gaming, and robotics. It's not just about creating replicas. Identifying 3D objects for something like self-driving cars is very important, but it represents its own set of challenges. The XYZ data points have to be extracted from the surfaces of all objects while also keeping them distinct from the background. 2D object detection has made many strides over the years, being significantly powerful with strong backbones and detection architectures. But when you put those same models to use in 3D detection, their performance is inadequate. If you're enjoying this video so far, be sure to leave a thumbs up and subscribe for more. But anyway, back to the video. A big issue with these previous methods was that they violated the principle of locality. This principle states that the object detector should only look at data points inside the space which contains the object of interest. Essentially, the detectors would look at objects outside the bounding box they were supposed to focus on, and so they would mark irrelevant data. DETR would make this mistake when used on 3D scans from the ScanNet V2 benchmark, while V-DETR wouldn't. When comparing the two, you can notice a massive improvement not only in V-DETR's ability to stick to subregions inside the bounding box, but also pay more attention to these subregions in the process. This is represented by the intensity of the color yellow, while blue shows low attention. The reason why DETR isn't so effective at this task is down to the lack of training data for 3D object detection specifically. Meanwhile, it works perfectly fine for 2D object detection. Creating or acquiring data to be used for 3D object detection training could result in significant costs. So these researchers have provided a simple but also very effective solution to this issue with their method known as 3DVRPE. Basically, it guides the model to focus on data points inside the box. It does this by providing each point with information regarding its location relative to the bounding box, so the model can tell whether or not the data point is inside or outside the box. So the model can focus its attention on items inside the box instead of going outside it. The 3D box itself is predicted by the model based on user queries, and it's said that the model is only getting better and better at predicting these boxes as it's being used. Furthermore, it can even take the rotation of the object into account to keep the position information consistent. This is done by rotating the 3D box and then predicting how the data points inside the box would change their position or orientation relative to the box's rotation. They gave us 2 examples of a chair facing away and also toward us. Even though the chair is rotated, the attention heat maps are fairly consistent from one scan to the other. They've also worked towards standardizing the input data and enhancing their network structure. They've opted for object-based normalization rather than scene-based normalization. What this means is that they're focusing on specific objects rather than the entire scene. The reason for this is that focusing on individual objects works much better and is more stable for point clouds. Meanwhile, in 2D detection, the sizes of the objects inside the image can vary due to various reasons because of the camera, like a high field of view massively enlarging objects at the corners of images. So let's take a look at how much better V-DETR is compared to DETR and other models. ScanNet V2 and Sun RGB-D are very challenging indoor 3D object detection benchmarks. The new model outperformed the previous one by a massive 19% on ScanNet V2. V-DETR obtained a rating of 66% while DETR obtained 47%. It's even outperforming the latest state-of-the-art models such as CA Group 3D on this benchmark by 4.7%. Overall, it seems to be outperforming every model that's been put through these benchmarks, either by a marginal amount or by a significant one. This is the most competent 3D object detector currently, at least for indoor objects, as this model is specifically for indoor object detection. But the researchers are keen on trying out this method for outdoor 3D object detection too, going away from the traditional approach that other 2D object detectors employ for outdoor objects. And if they can improve outdoor object detection, then it could be revolutionary for many industries, especially something like self-driving cars, where the life of the user heavily depends on how competent the algorithm is at scanning its environment. If you're excited about the potential of this technology, be sure to leave a comment below, and make sure to like and subscribe for more in the future.